Good morning, students. In the last class, we have discussed the modern trends, position of elements in the group and period according to the Henry Moseley in the modern periodic table. Can you remember it? Yes. Let me recap it. What we have seen is the elements are arranged in the period in the increasing order of atomic number. Okay, the increasing of atomic number, the elements are arranged in the period. In the group, how the elements are arranged? The elements are arranged based on the same valence electron, same valency. That is what we have discussed in the last class. Okay, can you remember it? Yes. Today, we are going to see the trends in modern periodic table. Okay, what are the things he has followed in the modern periodic table? We have seen last class position of elements in the modern periodic table and what are the ideas he has followed and what is in the modern periodic table we are going to see. Okay, the first thing we are going to discuss is about what is we are discussing today? Trends in modern periodic table. In that, we are going to first discuss about valency. Valency, now what it comes in your mind? Yes, the elements, each atom has its own atomic number. Based on the atomic number, it is denoted by Z, based on the number of electrons, the shells are filled. The shells are filled, and in that the outermost shell, that is called as valence shell. The outermost shell is called what? Valence shell. What is valence shell? The outermost shell. The outermost shell is called as valence shell, and it has some electrons. That electrons losing and gaining or sharing tendency is called as valency. How many electrons it gives, or how many electron it gains, or how many electron it shares, according to that only valency will be. So it is called the combining capacity of an element. The combining capacity of an element is called as valency. How it is determined? By the outermost shell, and the electrons present in that is called valence electrons. Okay, based on the valence electron, the combining capacity. The combining capacity of an element is called as valency. The combining capacity of an element is called as valency. That valency, how it varies in the period and group, we are going to see now. Already we have seen that is what is repeated so that you will know it, learn it better. So, valency, how it varies in the group. Let us see the group. Valency, how it will be in the group? Can you tell me? Yes, it will have same valency. That's what we have seen yesterday, no? Again, we will see with the second group. Last class we have seen the first group. Let us see with the second group. What is that? Beryllium. Group 2. It is group 2. Now, that beryllium, next one is magnesium, calcium. It is 4. It is 12. The atomic number is 4, 12. And for this, it is 20. So beryllium, magnesium, calcium. When you see this, okay, the splitting of electron is major role, okay. How it will be splitted? It belongs to second period, okay, second group, second period. So it will have two shells, okay. The electrons will be filled as 2, 2. Okay. If you see, this is the third period. How many shells it will be there? 3 shells. Very good. So it will be filled as 2, 8, 2. Okay. The next one is, it is the fourth period. Okay. It is fourth period. How it will be filled? 4 shells. 2, 8, 8, 2. Okay. When you see the same group of elements will have same number of electrons in the outermost shell, that is called valence shell, and the electrons present will be the same number 2, 2, 2. Okay, and here the shells will be increasing in 1 unit. See, it has 2 shells, it has 3 shells, and it has 4 shells. So that is what we have seen. Among that, what we have now, what is the thing we have to know it? Okay. Here, beryllium has 2. So L should have 8 electrons. What it will be doing? It will give the 2 electrons. Here also, it will give 2 electrons. Here also, it will give 2 electrons. It lose 2 electrons and become, okay, beryllium 2 plus, magnesium 2 plus, calcium 2 plus. So all the valencies are same. What is valency? The losing, gaining or sharing its electron is called as the combining capacity of an element. That is the valency. So when you see the group, the valency will be same. The valence electron will be same. The valency also will be same. So in group what happens? The valency remains same in the group. Now you can understand what happens to the valency in the group. It will remain the same. So valency in group will be same throughout the group. So it will be throughout the group will be same. But what happens to the valency? First group it will be 1. Second group it will be 2. Third, 13th or third group, you can see the valency will be 3. Next it will be 4. And again if you see it will reduce. That we will see in the period. Okay. So the valency will be same in group. So group 1 the valency will be 1. Group 2 the valency will be 2. So all the elements will have same valency throughout the group. Let us see the valency in period. Now we are going to see in period. Period means what? Horizontal rows. This one is vertical column. So here period, what happens? Let us see. So let us see period of 2. Okay. So the second period you can see it. So it will be, what are the elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. The valency will be, we will see the valency. 3, 4, 5, 6, 7, 8, 9, 10. Okay. How it will be splitting? It will be split as 2, 1. Here 2, 2. The shells will be same count. Electrons alone will be varying. 2, 3. 2, 4. Here 2, 5. Here 2, 6. Here 2, 7. Here 2, 8. So the number of shells remains the same, but what happened to the valency? Let us see the valency. Here the valency will be 1. It will lose 1 electron. Here the valency will be 2. Here the valency will be 3. Here the valency will be 4. When you come for this, I told you no 8, so that it will gain 3 electrons and it becomes 3. Here 8 minus 2, the valency is 2. Can you understand? 8 means it cannot leave the 5 electron. It has to spend more energy. So what it will do? It will gain electron. So 8, 3 electron is easy to get. 5 electron, it is little difficult. More energy should be spent. So there will be gaining electron. So it will become 3. Here it is 2, 8. In order to become 8, it needs to gain 1 electron. Here 0. So now you tell me what happens in the period, okay, when you go from left to right. So first it was what? 1, 2, 3, 4. Next it decreases. So first it will increase, next it will decrease. So the valency in the period, it starts to increase and then it will decrease. This is the thing happen in the period. So in the modern periodic table, whatever you say, take it will be increasing and decreasing, again it may increase. So the valency will be increasing, after that decreases. But in group, the valency will be same. In period, it increases and then decreases. This is the thing you should know in the modern periodic table, how the valency will be. Okay, shall we go for the next? Yes. So what happens to the valency in the group? It will be same. What happens to the valency in the period? It will increase, then it will decrease. That you should know. Okay, in that we have seen this. The next one is atomic size. Okay, first you should know what is atomic size. Okay, so we have seen that the distance between the nucleus, okay, the center of the nucleus to the outermost cell, okay, outermost shell. So from the center of the nucleus to the outermost shell, that is called as valence shell. That is called valence shell. Okay, the distance between the nucleus and the outermost shell is called the valence shell, and that is called atomic radius, and that is determined as atomic size. So atomic size is what? And that is the atomic radius from the center of the nucleus to the outermost shell. The distance between these two is called as atomic radius, and its unit is picometer. Okay, so this picometer, 1 picometer is equal to 10 power minus 12 meter. That is the unit of atomic radius. Okay, and this we have to determine, and how they have arranged we are going to see now. So atomic size is what? The distance between the nucleus to the outermost shell is called atomic radius. That size, that is the size, atomic size of the, by using this we can find the atomic size, and it has been given. We are going to see how it is arranged in the period and group. Okay. See here it is given first the period, second period. In period, okay, period 2 it is given. How the elements are arranged we will see. First we have to arrange in the decreasing order of atomic radius. First one is the lithium is the larger one. So lithium is more. So in decreasing order means the atomic radius should decrease. Like that we have to arrange. So lithium, next one is beryllium, next is boron, the next one is carbon, next nitrogen, next oxygen. When you see this period, the elements are arranged in the decreasing order of atomic size. Okay, so it is in the decreasing order of atomic size. We will see why it is decreasing. So we will see. First, when you see here the shells, okay, the shells will be only 2 shells because in the second period there will be 2 shells. When you see that atomic number is 3, 2, 1, it is 2, 2, it is 2, 3, it is 2, 4, it is 2, 3, 4, 5, 6, 7, 8. So it is 2, 5, it is 2, 6. Here the number of shells are same. First point is in the period the number of shells are same. First point, number of shells will be same. Okay. But the electron increases in 1 unit. So the electrons increase by 1 unit. Increase by 1 unit. So what happens when the electrons are increasing in the same shell? Protons also increases. So there will be attraction between positive charge and negative charge. So the atomic size decreases. What happens? So the number of shells are same. The electron increases by 1 unit. Same way the nucleus also increases. So the nucleus charge inside the nucleus will be more and the electrons are also closer. So what happened? They started to attract. So from the left to right, the force of attraction increases. Hence, atomic size decreases. So in the period, atomic size decreases. Okay, these are the points you should know it. Okay. So number of shells will be same. Electron increases by 1 unit. So the force of attraction between the positive and negative charge increases from left to right. So the atomic size started to decrease. So the period, the atomic size decreases. That is why when you are arranging, it has come from higher to lower, from left to right. Okay. The next one, you see the group. In group, it is given first group. Okay. So the sodium. Okay, you have to arrange here increasing order. You have to arrange in the increasing order. So what is the first one? Is lithium. Lithium is least. Next one is sodium. Next, it is potassium, rubidium, cesium, francium. Like that it comes, but up to this one is good. Now when you see here, okay, here the number of shells increase or decrease? Increase. So here 2, 1, 2, 8, 1, 2, 8, 8, 1, 2, 8, 8, 18, 1. So 2, like that it goes on increasing. So when you see the valence electron will be same, valency will be same, but it increases by 1 unit. So the shell in this will be 3 shells. Here, 2 shells. Here 3 shells. Here 4 shells. 5. Okay, it goes on increasing. So in the group, the atomic size obviously you see. If you see here from that, you will have 2 shells. So what is the distance? It will be this much. When you come to the sodium, it will be, so this is lithium, this is sodium. What happens? The shells increases, the distance between the nucleus and the outermost shell increases. Then what happens in group? The atomic size increases. Okay, that's all. It is increasing by 1 unit, the outermost shell. So obviously from the center, the outermost shell will have increasing in the shell will give the outcome of the atomic radius also will be increasing. Okay, it will be increasing. Okay, let us. What are the things we have seen today? We have seen how the valency and atomic size we will have in a short tablet called. So in period and group, valency will be in the period. increasing. Okay, that is what we have seen today. So today what we have seen in the modern periodic table, the valency will be in the period increasing then decreasing, and in group it will be same, and in the atomic size will be decreasing in the period and increases in the group. Okay, we will see the metallic and non-metallic character in period and group in the next class. Thank you.